Welcome to Regression Tutorial 1. In this tutorial, we introduce the concept of dummy variables in regressions. In this tutorial, we are using linear regression to predict the price of bottles of Pinot Noirs. As dependent variables that help us to explain the difference in prices of wine, we use the points Robert Parker assigned to this wine. We also use the age of the vineyard where the wine is coming from, how many awards this vineyard has recently won, and how many recent write-ups there were about this particular vineyard. Finally, we are particularly interested in finding out whether or not it matters if this wine is from California. As a matter of fact, this is our prime question in this regression. Does it matter if a wine comes from California, i.e. is there a price premium for California Pinot Noirs, or is there a price penalty for Californian Pinot Noirs? So what we do, we add California as a fifth independent variable, and since there is no real value, numerical value associated with California, we assign arbitrarily a 1 for a wine being from California and a 0 for a wine not being from California. So the first 10 wines, in our case, are not from California, but wine number 11 is the first wine from California. Similarly, wine number 22 is from California, and so on. In total, we have 114 different data points. So we looked at 114 different bottles of wine to predict the prices of a bottle of wine. So now we are ready to run a regression over our data. As usual, we go to the Data tab, to Data Analysis, choose Regression, and as the input range, we use range B1 to B115 for the input Y range for our Y variables, our dependent variable. And for our independent variable, the input X range, we use the range from C1 to G115. Let's make sure we have labels. Let's call this new worksheet ply total regression, and let's hit OK. And this is our output. Now, I don't like to look at output like that, so before I actually do some major work with this, and in particular before I present this to anyone, I usually clean it up so that it looks something like that. This looks better. R square at 75%, that looks very good. The coefficients for points, age of vineyards, recent vineyard awards, and recent write-ups, the signs are as you would have suspected, but let's look at the coefficient for California. The coefficient of minus 0.634 for California means that California wines, all other things equal, experience a penalty of 63 cents per bottle. So, since we are mainly interested here in how do California wines compare with others, our result would be, well, actually, they do incur a penalty. However, the p-value for California is rather bad, so in this particular regression, we would not be confident to say that there's any price penalty or any price premium for wines from California. Nevertheless, with the remaining factors, it looks like we have a decent model. However, we are not going further into discussing p-values and further improving the model. That you can learn in a second tutorial. Instead, we are looking next at the scenario where we don't have just one region, but multiple regions. Let us now look at the case where we have multiple regions. We have wines from Burgundy, the original region of Pinot Noirs, from other areas of France, from Australia, from Oregon, and from California. And then we have wines such, say, from Italy, from New Zealand, that are not from any of these regions, and we just group them into others because we cannot list all the different areas where Pinot Noir grapes grow. So let's try again what we've just done and run a regression over the entire data set. As usual, we start with going to our Data tab, look for Data Analysis, find Regression, and our regression input range Y, still in from before, B1 to B15, but our input X range is now from C1 to L115. Again, we have labels. Let's call this total regression all. Hit OK. After we clean up the data, the regression looks something like this. The regression looks overall fairly nice. However, look at what happens with Oregon. Something with Oregon doesn't seem right. The coefficient is 0, the p-value it cannot figure out, the t-statistic is quite large. Something here must have gone wrong. Indeed, something did go wrong, and indeed, actually Excel should not even be able to calculate the results. What went wrong was that we have Burgundy, other France, Australia, Oregon, California, and others. So we have 6 different regions, and we have 6 dummy variables. Now, if you recollect, when we had only California as a region, we had basically 2 regions, California and other. However, then we only had 1 dummy variable because it was clear you're either from California or from the other regions. Similarly, here it is clear you're either from Burgundy, other France, Australia, Oregon, or California. And if you're from none of these regions, you must be from other. Therefore, we overspecify our model. Basically, one of the 6 dummy variables here is redundant, and for some reason, by chance, it picks Oregon and says, well, I cannot deal with Oregon, and I try to do my best ignoring Oregon and do regression for the other states. So what we need to do, instead of running a regression with 6 dummy variables, we simply run one with 5, and it's most natural to take others out, because then the default is that a wine is from one of the other regions, but only if it's from either Burgundy, other France, Australia, Oregon, or California, it is specifically marked with a variable. So let's try this again, and then the results looks like this. So now the results look okay, no more error terms with Oregon or any of the other variables. And now let's have a look at the coefficient. For now we will ignore the p-values. If you look at the p-values, the regression is not particularly good. We will do that in the next tutorial, how to narrow down this regression. So now let's have a look at the coefficients. Each Robert Parker point would mean 73 cents per bottle extra. Each additional year of the vineyard's age would mean 4 cents per bottle. Each recent vineyard award would mean 63 cents. Each recent write-up 1 cent. A bottle from Burgundy would fetch a $1.21 price premium over, well, that is the question now, over which areas? Well, since the default is the other regions, so Burgundy would fetch a price premium of $1.21 over wines from other regions. A bottle from other areas of the France, however, would be, all other things equal, 99 cents less than wines from other regions. From Australia, we would have a 17 cents price premium over other regions. Oregon, a 33 cent price premium. And finally, California, a 57 cents penalty. However, we know, since the p-values are pretty dismal for some of our variables, that we should take some variables out. This I will do in the next tutorial, reducing this regression to a concise model that is very telling with as few variables as possible. So please stay tuned to the next tutorial, where we will reduce this regression, make it a parsimonious model, and then afterwards we'll validate the regression, and finally we'll test it.